As we move forwards, we are now going to have to use a lot of information we've previously learned to continue our studies. So you have to remember how to use your naming rules. So if you don't remember how to do ionic naming rules and covalent naming rules, you need to go back to those lessons and review them because you're going to need that skill moving forwards with our chemical reactions. So how do you know a chemical reaction is taking place? Because sometimes you can mix together two substances and nothing happens. They simply mix together. But sometimes they will interact with one another and they will change their identities. That's a chemical reaction, a chemical change. Here are some of the ways you can tell that that has happened. Sometimes they interact explosively, and so you have heat, light, fire. Sometimes they'll make a gas. So if you pour two liquids together and you see bubbles forming, you know you're forming a gas. What you see here in this little video clip is the formation of a precipitate. That means that it is making a solid. Okay, so when it forms a solid, that's called a precipitate. We're also witnessing a color change happening. Something else that could be a sign of a chemical reaction is a new smell that wasn't there before. That could also be a sign. As we're working with our chemical reactions, we need to remember the law of conservation of mass, meaning that even within a chemical reaction, when the substances are changing their identities because they are changing what chemicals they're interacting with, we are not creating any new mass. Mass is neither created nor destroyed. So what you start with is what you end with as far as mass goes and atoms. Okay, so if we start with 4 grams of hydrogen and 32 grams of oxygen, then our mass is 32 plus 4. That means that our outgoing mass has to be 36 grams. Okay, same starting, same ending. Same with atoms. As we see here, we started with 4 hydrogens and 2 oxygens. And when we were finished, we still had 4 hydrogens and 2 oxygens. But they're interacting differently now because a chemical reaction occurred. They went from being just hydrogens and just oxygens to being water, or if we use our naming rules, dihydrogen monoxides. Okay, let's talk about some vocabulary that we're going to use so that we can use proper terminology as we work with these equations. When you're talking about what goes into a chemical reaction, you're talking about the reactants. Those are the ingredients. When you are talking about what comes out of the chemical reaction, what is the ending? That is the products. Those are your products or your outcomes. We're also going to see a lot of symbols in these chemical equations, so we want to make sure we know what those are. If you see the arrow, that represents the chemical reaction occurring. So you can read that as produces or forms or creates. The plus sign, you can read that as plus or and, or you could say reacts with, and we're going to see some examples of these in use. Okay. We also need to represent what physical state our substances are in. So we do that by writing in parentheses after the chemical formula. If it's a solid, we use an S, liquids get an L, gases get a G. Now something new is aqueous. Okay, so AQ. So this is new to us. We haven't heard this term in this class yet. So aqueous simply means that it is a solid that is dissolved in water. So for example, if you make salt water, okay, salt is sodium chloride. So that means that you have aqueous sodium chloride when you make salt water. If you need to heat the substances in order for the chemical reaction to occur, we represent that by drawing a delta on top of the arrow. And so it looks like a little triangle. The delta symbol is a little triangle. Okay? And that simply means we had to heat. So let's take a look at an equation and all these different bits and pieces, because there's so much information cram-packed into that little equation. Okay, so we're going to use symbols to show how many. So the coefficients, that's what these big numbers in front of the symbols mean. Those are coefficients. That means how many of them. So this means 2 hydrogen molecules. This means 2 waters or 2 dihydrogen monoxides. How come oxygen right here? Why isn't there a number there? That's because there's only 1 oxygen molecule. So we don't draw the ones, okay? Those are understood. It also tells us of what. That's the chemical formula. So, 2 H2s. So remember those diatomic elements. Remember on your periodic table that pattern that you see. Hydrogen is diatomic. So if you have hydrogen by itself, it's not going to be just H. It has to be H2. Same goes for oxygen. It's another diatomic. So we have 1 oxygen. Okay, 2 waters, dihydrogen monoxide. So the chemical formula tells you what the substances are. And then we can also say in what state. So what physical state are they in? In this particular example, they're all gaseous. So they're all in the gas state. So let's look at an example of what you're going to be doing on your independent practice. So you're going to be given a description of a chemical reaction. It's going to look like a paragraph like this. And your job is going to be to turn it into an equation. So let's start by identifying all the substances. We have aluminum, we have copper 2 chloride, we have copper, we have aluminum chloride. Okay? Next, you want to make sure you are asking yourself how many, of what, and in what state for each of these items. So let's start at the beginning and let's write out the chemical equation. So 2 atoms of solid aluminum. So how many? 2. Of what? Aluminum. So we need to check. We're going to look on our periodic table. We're going to see aluminum is Al. We see aluminum is not diatomic, so it can be by itself, so Al. And then in what state? Solid, so S in parentheses. Okay, next, react with, that's my plus sign. 3 of something, so let's go ahead and write plus 3. Okay, so how many? 3 of what? Copper 2 chloride. All right, so let's check this out for our naming rules. So copper is a metal, chlorine is a non-metal, so ionic naming rules. Okay, copper 2, that 2 means that copper has a charge of plus 2. Chlorine, because of its location on the periodic table, is a -1. 2 and 1 do not cancel off, so we have to do the crisscross, CuCl2. Go back to your ionic nomenclature lesson if you need to review that. Next it says, that's how many? 3 of what? CuCl2. In what state? Come back up. It says that it's aqueous, so AQ. Okay, 2 produce, time for my arrow. 3, okay, so put my 3 there. How many? 3. Of what? Copper. So go to my periodic table. That's a Cu. It is not diatomic, so it can be alone. Cu. In what state? Okay, copper by itself is always a solid, so S. And plus sign, 2 plus 2. Okay, of what? Aluminum chloride. Using my naming rules, aluminum is a metal, chlorine non-metal, so I need to use my ionic naming rules again. Aluminum, because of its location on the periodic table, is a +3. Chlorine is a -1, so I got to do that crisscross again, AlCl3. Again, if you don't know where I'm getting these numbers from, go back to your ionic nomenclature lesson. Okay, and in what state is that aluminum chloride? It says right here, aqueous. So add my AQ, and I have now completed my equation. Now let's take a look at some of the terminology that was used in that paragraph that you'll need to know how to use properly. What kinds of words are we going to use to go along with these coefficients? Okay, if you have an individual atom all by itself, then that's what we do. We call it an atom, such as I said we had an atom of copper. If you have a covalent substance, so remember covalent means that you have 2 non-metals bonded, then we're going to call that a molecule. So your diatomic elements are molecules. So you have a molecule of oxygen or a molecule of iodine. If you have an ionic substance, remember these are where you give and take electrons. So this is a metal with a nonmetal, then we call it a unit. Okay? So here are some examples for you. 3CO2. So carbon is a nonmetal, oxygen is a nonmetal. So this is going to be covalent, so we're going to call it a molecule, and we need to use our covalent naming rules. So this would be 3 molecules of carbon dioxide. Okay, Mg, that's an element by itself, nothing else. So we're going to say 2 atoms of magnesium. MgO, Mg, that's a metal. O is a nonmetal. Got to use our ionic naming rules. So that's going to be 4 units of magnesium oxide. Magnesium is not a transition metal, so I don't need a Roman numeral there. Okay, so be careful. These 3 words are really important, so make sure that you are using the correct term with the correct coefficient. Okay, so atoms, molecules, and units. And then we can also do the reverse of what we just did. So here is an equation. You have to write it in descriptive form. This is something else you're going to have to do on your independent practice in just a little bit. Okay, and so remember the questions. How many, of what, and in what state? Okay, so you just start at the beginning. So how many, there's no coefficient, that's an understood 1. So I have 1 atom of what? Zinc, 1. And in what state? Solid. So I have 1 atom of solid zinc. Okay, next, the plus sign. So how do I want to say that? I'm going to say reacts with. You could write and if you wanted. You could say plus, that's okay too. So reacts with, and then again, how many, of what, and in what state? I have 2 molecules of aqueous hydrochloric acid. Okay, hydrogen is a nonmetal, chlorine is a nonmetal, so I use the term molecule. 2 molecules of aqueous hydrochloric acid. Okay, now I have to write out what my arrow means. So I'm going to say to produce, and then again, how many, of what, and in what state. Okay, naming rules. Okay, I've got zinc. We know that that's a metal. Chlorine is a non-metal. Zinc is a transition metal. All those naming rules to be able to properly name what this thing is. Okay, I have 1 unit of aqueous zinc 2 chloride. Okay, now I have to represent my plus sign, and then again, how many, of what, and in what state. 1 molecule of hydrogen gas, because it's hydrogen by itself, but it's diatomic, so it's H2. So since it's diatomic, that's a hydrogen bonded with a hydrogen. That makes it a molecule. So as you can see, knowing those naming rules and knowing those diatomic elements and understanding bonding, super, super, super important. So go back and review those lessons or those notes if you need to. That way you are ready to go do your independent practice. And get into contact with me if you need some help.